Okay, so do you guys have any more questions? Any more questions about so basically everything that happened in lab is pass fail. So that's why you don't get like a lot of letter grades or anything. So everything that happens in lab is pass fail, and then you get your letter grade for the classroom portion. Okay, so so what we're going to do today, so over here in the Moodle, you'll see there's this trivia PowerPoint. And I'm just leaving that in here for you guys to work on, use it as a study tool on your own. We're not actually going to do this in class. Here's just the PowerPoint, and then here's the PowerPoint with the answers. So if I were you, probably the best way to do it is to start out without being tempted with the answers. Try and answer all these questions without seeing the answers first, and then you can go into here and check your information. But that'll give you the best way. And then here I had found these last year. They're just panos with common errors. So I had put them down here for, whatever reason. I think there's probably several questions on the exam having to do with pano errors. So I just put those down there for extra study. And then here's a study guide for you guys to fill in that, again, just the same way, just information to focus on. And then here's the Kahoot game that I'll unhide after today, but I'm going to pull that up. We'll play that, and I'll record us playing it too, and I'll post the recording. So you can watch the recording, or you can just go in and play the Kahoot again. And then that's all really that. And then this recording is from last year, so I'm not going to unhide that. That's has students. Yeah, Tala. Yeah.
Or focus more on each core point, because just in case you have not enough time to do all these together, which one do you prefer?
I think it would be really good for you to focus on the study guide and then these trivia and the Kahoots. I think those would be a good place to start. And then this is a cumulative. So everything that was focused on the other exams, so study guides from the previous exams, reviewing those study notes that you took after you've gone through here, just to maybe fill in some knowledge gaps and just looking back at what you have done. I think that would probably be the most beneficial, as opposed to just trying to tackle each PowerPoint. I think that would probably not, or looking at each chapter in the book and like trying to all of a sudden say, I'm going to read the whole book in a weekend, I think it would be better to just use this study guide and these games, the Kahoot and the trivia, and then just look back at your old study notes for the other exams. Because really everything, pretty much anything that was on those old exams very likely will be touched on. And I mean, there's always an exception. There's always going to be something somewhere that's like, I don't even remember studying that. There's always an oddball question, but for the vast majority that that you need to be able to pass, with a good grade, it'll be stuff that it's going to be stuff that we already talked about, and stuff that you just need to remind yourself of and stuff. And a lot of that you'll see in the study guide already. It'll talk about, and then you can reference back. You can say, oh, this is talking about KVP and MA or contrast. And so let me just go and refresh myself on those topics. I'm going to be proctoring the afternoon. So it'll be the case studies. So I'll be there from like after whatever time the lunch time starts to like 3 o'clock is when I'll be there.
So the first one is going to be almost case-based. What about the labeling? Are they going to be second, or is no labeling?
I don't think there's any labeling. I think it's all multiple choice, even the cases, and I think the whole thing is multiple choice.
So what about the pano or the anatomy?
So that might be a question where they might say, like, it might show a picture just like the landmark exam, and then it might say, so say it's a picture of the, like the median palatine suture, that radio lucent line between 8 and 9. It might show that and then put arrows to it. And then it'll give you 4 options. Like it'll say the median palatine suture, and then it might say the you know, whatever, 3 other things that are in that area, or maybe not even, you know, in that area. And it'll just give you a multiple choice. Oh yeah, there's images. Yeah, there are some images for sure. Yeah. And the images are tricky. I hate the way the images show up different on everybody's. Yeah, Ryan. Go ahead. The trivia? Oh no, you can work through this any way you want. It's just a PowerPoint. I'm just not going to do it in class. But then the ones with the answers. So I would say, and kind of do the PowerPoint first. So pull up this first one that says Trivia 2019. I don't know why it's taking a while for it to pull up on my computer here. So, so it has these slides, and they're just questions. And see, it says stuff like round 1 and blah, blah, because it's a game, but I didn't make this, and I don't really know exactly how it's played because the instructions are not there. I mean, I get it's questions, and there's like teams, but I'm just like, I don't know how the person that created it visualized it being played. So I'm just giving it to you guys as practice questions. So like, how much percentage is it to take digital film compared to traditional? How much less percentage? And so the answer is in the same PowerPoint, just with the answers in the notes section. But if I were you, I'd pull up this one first and give your best to answer it. And then you can pull up the other one and see that the answer, which is like 50%. So that's the other reason I might not have done it, because I would have had to go through and like rewrite the questions to, because maybe, but how much lower percent is it to take digital films compared to traditional? So lower percent of radiation. How much lower percent of radiation? You did learn it. You did learn it. There's a lot, you know, one of the things that is like kind of a mainstay in this whole program is you'll learn something one day for an hour, and then a couple weeks later, it might come up. And then you'll be like, I swear we never covered that. And it's like, well, we did for like 30 minutes amongst a million other things that we talked about. And now you have to try. So it's not uncommon to feel that way because there is so much information. And so don't ever, you know, don't be hard on yourself, but that's just part of the reality of being in a program that has like a huge amount of curriculum content. Ryan. I made the study guide, but I would use this too. I mean, I know that first question was kind of weird, I guess, but it's also kind of like, if you think about it for a few minutes, it's like, well, percentage of what? Percentage of how much it gets used in an office, and you know, you'd kind of think about it, and then you might come to the conclusion of radiation, because that's a very important piece of taking x-rays, is how much is our patient getting radiated. So it kind of, I don't know, it might lead you to that conclusion, or maybe not, or you can just email me and say, what is this even talking about? So anyway, so that's why I didn't focus on this one too much, because I didn't actually create it, but I did create the Kahoot, which we'll do next here. So anyway, so yeah, so this is that trivia. That's what I was just looking at. There's some couple of things on pano errors. I made the study guide here, and then we're going to do the Kahoot game. Tala, did you have another question?
Yeah.
The only real similarity is the content. So the questions may end up being similar just out of a coincidence, but I'm not saying that it's a question similarity. It's more like I was trying to prep you on the content more than anything. Yeah. Okay, so you guys want to get going? You want to play it? Okay, let me pull it up here.
A lobster.
So I'm just noticing, I'm looking at it and I'm realizing that I didn't adjust the time. So most of the time questions only have 20 to 30 seconds. And sometimes so that's pretty quick. But
Well, that's what Yafi did one year.
is okay. So it's pretty quick. And if you know what's good about this is you can replay it or you can watch the video. And so if it takes you longer than 20 seconds to figure out the question and answer it, you can, that's why it's a study tool, right? You can do it some more. So, okay. It might take it would probably take me 10 seconds to at least absorb the question. So I understand I don't love tests either. I've never been like the biggest test taker. Okay. So I think okay, so there's your pen. And I gotta share this. Hold on.
I should have been thinking that.
Somebody be taking out to dinner.
As long as you
You like it?
what? Let's go big on. Mom, you have
No, I would check that for sure.
You never heard that? No, but that's the one. Yeah.
You need to get on there.
Let's take
Oh, yeah, I made my, oh, baby. I made my, baby.
Oh my God.
But I obviously.
There's too many words there.
Can I do them all?
Okay, 32. We got everybody. I'm so excited. Yep. And I didn't review my question, so I could have written a silly question that I meant to adjust and then print. So the collimator is the donut shaped thing at the end of the X-ray tube before the BID, and it's lead, and it's going to restrict the size of the beam. So it's going to restrict the shape and the size of your beam. The collimator. No, we alpaca. Epithelial lining. Oh, epithelial lining. Good. Yep. So the cysts are the lesions. So a lesion can be an abscess or a cyst or a granuloma or whatever. And the cysts are the one with the epithelial lining. What do you need to generate or to produce X-rays? What do you need to generate to produce an X-ray? Electrons, very good. So your tungsten filament, that thermionic emission is boiling off electrons to make in order to produce the X-ray. So when the electrons hit the tungsten target, that's what makes the photons. The X-ray photon. Okay. Your patient is a large guy with thick cheek muscles and a large mandible. How will this affect the density of your film? No effect, low density, high density.
It's tricky. I'm going with my best guess.
So yeah, it's not asking about contrast, but so a high density film and a low density film, but we're thinking it's going to make your film lighter. I don't love that question. I would have actually answered it differently. But basically, what I think I was trying to get across in that one when I wrote it is that if they have thick bone, thick muscle, that's more for the X-ray to penetrate. And so your film's going to be lighter. So you're going to need a little bit more, a little bit higher exposure time. You're going to, something like that, a little more power to penetrate all that and give a good film. Yeah.
What I've been doing is say a dense man makes a low density film.
Oh, that's good. If it's a big, yeah. And you can think of, like just bigger, thicker structures just is more material, but that's good, Katie. That's good. Okay.
Oh, baby.
Both KVP and MA are set high on your X-ray machine. How will this affect density? So both KVP and MA are set high. I know. High density. So more power, more available electrons is going to lead to potentially higher density or a darker film. High density causes your film to look light, blurry, dark, black, gray. Yeah, so a higher density is a darker, the overall darkness of a film. So darker film.
I'm on fire!
An X-ray photon that is completely absorbed by a structure and never makes it to the film will appear how on the film? So the photon never makes it to the sensor. The X-ray photon never hits the sensor. What will that part of the sensor look like? White, yeah. So if a whole bunch of stuff gets to the sensor, it's going to be darker. If nothing gets to the sensor or less stuff gets to the sensor, it'll be lighter. So if you think about it, like everything sometimes works a little bit better when you think about it in like real life, like what actually is happening. So on a digital sensor, the coupling device, you have all those pixels, and those pixels have to be like affected by your X-ray photons, and that's what's going to create the dark parts. Or if you think about it as a traditional film, that's coated in that emulsion, that's the crystal, the silver halide crystals, they have to be hit by the X-ray photons in order to become dark. So whether it's a pixel or it's a crystal, we don't use traditional films, but they have to be hit by photons in order to turn dark. So anything that, if part of those two things that don't turn dark end up being, if it's a traditional film, it's just washed away and it's clear, or if it's a digital film, it looks white. That gives you the whiter spots. So sometimes it just helps when you think about the reality of what's really happening in order to help you remember those kinds of questions.
Bring me back.
Where'd you go? Oh, you're still there. The charged coupling device has a smaller active imaging area than a traditional film. The charged coupling device has a smaller active imaging. Say it again. To this? Yeah. So the charged coupling device is your digital sensor, and they're getting better at this with the design, but the first ones were real boxy, and in just a little inside portion of it was like active, or the picture would show up on. So they had to make it bigger than what was actually usable. And so I hated them. The first ones, I hated them because they're thick and big and square, and it was bad. But now they're smaller in general, and the active space fits more to the true size of the digital coupling. But with a traditional film, every single part of that was an active, and then you could bend it and stuff. So there's just different characteristics. But it's better now. The active imaging area is more true to the size of the sensor. But there still is a little bit of difference, obviously, just because they have plastic and stuff that gets in the way. Good job, you guys. Okay. Contrast refers to the shades of gray, the overall blackness of a film, or the lightness of a film. Shades of gray, good. So the overall blackness is the density, shades of gray is the contrast. Good. Good. Your radiographs have too high of a contrast. This can be corrected by doing which of the following: increasing your KVP, increasing MA, decreasing KVP, increasing exposure time. Contrast is too high. So I know this is one of those ones that it messes with your mind, and it's a hard concept. So if your contrast is high, you have a lot of black and white. It's just, you don't have a lot of shades of gray. So if your contrast is high, you got a lot of black and a lot of white. If you increase the power, you'll have better penetrating X-ray photons that will get through all the structures, and then you'll have shades of gray, which is low contrast. So I know. But that's a good one because you guys really need to know it for the exam. You know it's going to be on the exam. So just know that you just have to think about what throws you is the increasing, decreasing, low, high, that all of those different words kind of, it just makes it feel confusing. But yeah, high contrast. So think about, there's a high contrast between white and black, right? White and black, very big contrast between those. Low contrast, lots and lots of shades of gray, like a gradient. What's it when people did their hair? And ombre. So think of low contrast as ombre. It's like that. And in order to get that ombre, you need to have strong chemicals. So you need you need to increase your KVP, you need more power in order to get that gradation or that graduation. I know, I don't know. Trying to come up with something. Hell, because I know it's a hard story to get straight. Bing bong, bing bong. Okay, if you have high KVP, you will have low contrast, lots of shades of gray, high contrast, lots of shades of gray, low contrast, more black and white, high contrast, more black and white. I know. Yay! So lots of shades of gray. Well, lots of more black and white would be just well, if you mix them, but if it's just black and white, if it's just black, then that's still low contrast or high contrast. See, don't let me talk about it too long or else I'll say the wrong thing too. So yeah, low contrast is lots of shades of gray, which is optimal. That's what we want. And we get that with a higher KVP. What is the filter in the tube head made of? Lead, tungsten, copper, or aluminum?
Wrong one.
Aluminum. So there's lots of different metals. The collimator is lead. The filter is aluminum. Tungsten is the wire where the electrons heat up, but tungsten's also on the target. And then copper is on the anode side that absorbs the heat. So all of those metals are in there. So, you know, it might be helpful to just write a little chart and just so that helps you put the pieces where they're supposed to. But yeah, Jenny. Yeah, because it's like on the back side of the anode and it helps to absorb all the heat. So that's what the copper is for. So you could just say absorbs heat, copper. Anode side absorbs heat or something. Your life up. Contrast is affected by MA and KVP. True or false? False, yeah. So contrast is only really affected by not the number, because remember MA is the number of electrons, but KVP is like the power, and contrast is really only affected by the power. So density is affected by MA though, but contrast is only affected by KVP. Okay, an X-ray machine with a KVP of 69 will have what thickness of filtration? So remember it's like the filter has to be a certain thickness up to a specific KVP, and then past that number, it has to be a different thickness. So it's 1.1. So it's either 1.5 or 2.5. So if it's higher than 70, it's 2.5. If it's lower than 70, it's 1.5 millimeters. So ours are all, well, actually 2 of our machines now are higher than the other ones. So we might have 2 different filters. So 69 and lower is 1.5. Anything 70 and above are 2.1. The main radiation that's produced in most tube heads is, I don't know if is was right, or maybe it should have been R, Bremsstrahlung characteristic scatter secondary, the main radiation that's produced. I know what this was long ago. This was Bremsstrahlung, good. So yeah, so characteristic has to be over certain kVp, and most machines are calibrated and put to 1 kVp, and they produce mostly Bremsstrahlung. Characteristic radiation can only be produced by blank kVp and higher. So the kVp is usually, on our 2 new machines, it can be either 65 or 70, but our other ones are set at a certain number, and you can always go in the lab and look. But 70. So if it's higher, if it's 70 or higher, then it can produce characteristic. So most of ours, at least, well, 2 of ours are Bremsstrahlung, and then those other 2, I actually don't know, because you can change it. So they could be making characteristic, I guess. I'll have to. The tech is coming back this week. Maybe I'll talk to him. He probably doesn't even know. He'll probably look at me like, what are you even talking about? Okay, the cathode has a blank charge, positive or negative. Because it was 15 weeks ago. Negative. Yep. So remember, like cats are, there's like a thing about cats being negative or something like that. Catnap. Yes. Cats, negative anode. Wait, what does that stand for? What? I know. Cat. A anode.
The A didn't see nothing. It was just C and then negative in the cap. Negative. Anode positive.
Anode. Oh, because the anode is positive. Yeah. So cathode negative. So you anode positive. Okay, it's just C for cathode. Okay. And then you can use that as a dual thing, because some people think cats are aloof and negative or something. I don't know. That's just what some people think. Cats have like an uppity attitude and they're negative. I don't know. It does. It's very discriminatory toward cats, frankly, I think. But cats aren't necessarily negative. Okay, the step down transformer. This is a lot of information. Controlled by kVp and heats up the tungsten filament. Controlled by Ma and sends electrons to the anode. Controlled by kVp, sends electrons to the anode. Controlled by Ma, heats up the tungsten filament. Good grief. Step down. So it's going, one thing that'll help you here. We'll see how the results come out. That was all over the place. This is a hard one. So what couple things that you can will help you remember this is, if it's a step down, it's reducing power. You can just think step down, reduce, like that can just kind of help you. And if it's reducing power, well, so what a couple things you have to remember is that the Ma only requires to heat up the tungsten filament. It requires very little power. So when you think of kVp, you might think of like lots of power. We need it to be strong. Like you might think of it as a power boost, something that needs a lot of power. But in Ma, in order to heat up that filament and get electrons, it doesn't take a lot of power. So you just have to sort of remind yourself of all these things that we talked about several weeks ago. So step down, reducing power. The MA doesn't need a lot of power to get the thermionic emission or create the electron cloud. We don't need a lot of power there. So that's why that kind of helps you with that story that it's controlled by the MA. And then what it's doing is it's taking the power from the wall. So the power is coming out of the wall, turning it way down because you don't need a lot of power to heat up the tungsten filament. So it's controlled by the MA to heat up the tungsten filament, to create electrons. So that's what the step down transformer is doing. It's reducing power from the wall to reduce it because you don't need that much power for MA, for the tungsten filament. On the flip side of that, I'm not sure what the next question is, but on the flip side of that, you have your step up transformer. Now we can think of increasing power, stepping up, giving yourself more power. And we need something like, remember our KVP, when we say our KVP is 69 or 70, we're talking about 1,000 kilowatts. Like we're talking about lots of power. We just say 69 and 70, and it doesn't sound like that much, but we're talking about really a lot of power. So now the power from the wall, the plug, the 110 voltage or whatever, now we're stepping up, increasing our power and shooting the electrons across from the filament to the tungsten target. We need lots of power to get them to move over to the other side. So that's where the step up and the step down come in, if you remember that. Step down, reduce power. MA, we don't need a lot. It's to generate electrons. Step up, KVP, we need more power to fly across to the anode. Little walk down memory lane, which is positive. Which is positive. Okay. Okay, when an electron is ejected from its shell, creating an ion pair, it's called ionization, excitation, radiolysis, free radical. When an electron is ejected from its shell, creating an ion pair. Ionization. Good. You guys remember that. Ionization. Excitation is just when the things it's talking more about our biology and like human cells, and like things get a little bit like vibratory, and it can cause damage and break apart, but usually it just vibrates and then settles back down. So we don't necessarily get cellular damage when there's excitation, but we also can. So it can do one of the two things. Okay, development of cataracts from radiation is an example of a somatic effect, an indirect effect, a genetic effect, or a direct effect. Somatic, good. So remember, there's the two kinds. There's the kind that happens to the person receiving the radiation, and then there's damage to their genetic material that might affect their offspring, and that's somatic. I mean, genetic, sorry. That's genetic. Indirect and direct, I was trying to think of how that is different, because one is happening directly to the cell. I think that has to do with the radiolysis and so one is happening like, bam, you're going right to the chemicals of life and you're affecting the DNA. The other one is you get radiolysis, you get damage, but then you end up with damage. It just maybe is like a longer path to getting cellular damage. I know for a minute I was like, how is that different from? Let me remember. Okay, radiopaque landmark is on, the radiopaque landmark is on the, oh my word, we're never gonna figure this out in 22 seconds.
Where's the radiopaque landmark?
Don't worry about answering it right. Let's just look at this together.
Oh, that's true.
Oh, you want me to give you the answer? I don't have it memorized. the palatal root went distal. So that means that, and it went, shoot. So the palatal root went distal. Let's get the picture up here. Hold on. No, there is a question of buccal object rule on the final. There is a question. So that's why I put this on here. So the palatal. Okay, so the way we would figure this out, this is so tiny. Okay, I know this is the, oh, you know what, you guys? You don't even need to know the buccal object rule to know the answer to this. Because the opaque, I mean, this is a buccal object rule question, but look at this. This is what it's basically saying. It's asking about the opaque structure, and it's pointing to the zygomatic process. Where's your zygomatic process? It's on the buccal. So you don't even need to know. I'm not a good test taker either, you guys. See, it took me a second. Yeah. But let's say, well, so let's talk. I know you guys can't see this very well, but let's just talk about it in terms of if it really truly wasn't just a landmark that happens to be on the buccal, that it's just like a floating radiopaque thing that you're trying to figure out if it's buccal or lingual. So the way you handle this is you look at your most straight on, least distorted image. So you're going to pick the one, and I'm picking this one because you see all the roots are nice and kind of straight. There's not so much overlapping. There's not so much blurriness. And so I'm picking this as my main, my baseline, right? So you look at your baseline, you know that your lower cusps are buccal. These are always buccal. And then you know that the root in the middle is your palatal root. And then what I didn't even think of, because I was panicking as well along with you guys, was that it's a zygomatic process. So it's a buccal object. So all of those things, you know where they are in the image. If it's asking about something's orientation or its buccal or lingual position, find the things that you know are always buccal. Find the things that you know will be lingual. So we have the palatal, we have these. So then we look at the second image and we look at how they moved. So so it's buccal same. So if the buccal structures moved mesial, then we look at how the palatal structure moved, and that should have moved distal. So over here, so we look at the palatal root, it went distal. We look at the buccal cusps, they moved mesial. So then we know the beam moved mesial. And then we can do the same thing with the buccal object that we know is buccal. It came into the image more. From here to here, it moved mesial as well. We see more of the zygomatic process. So we could have answered this question without having to think of all of those orientations, just because we know that this is a buccal landmark. So we kind of panicked. So I don't know how I honestly, 100% telling you the truth, don't remember the question, and if it's something very similar to this, or if it's like a piece of amalgam or something that they're trying to say. But that's how you'll try to figure it out. Look for the things that you know are buccal. Look at how the cusps in the picture went from your baseline to the second image. Did your cusps move more mesial? Then you know anything that's buccal will have moved mesial in that second image. If something you know is lingual or palatal moved opposite, you know anything in that image that also moves opposite is going to be lingual. So I know it's not fun, and it'll probably give, and I think there's only one. So out of 100 radiology questions, I think there's only one buccal object rule question. So if you get it wrong, it's not the end of the world. That's what I'm trying to say. Each question is worth a half a point for, what if you get them all? Well, that's different. That's a whole different thing if you get them all wrong. But I mean, but see how we could have answered this without even knowing any of that. So I hope the question is sort of like that. I honestly don't remember. But look, most of you said buckle. So that was good. Most of you said it anyways. Some of you guessed right. Some of you might have already figured it out. Okay, so the white dot would be on the, so the white dot, so here's another, I know there's not enough time to figure this out, but look at what we know about this image here, what we know about this landmark here. I know you guys can't see it. So this dark spot stayed under the second premolar. In the next image, this dark spot stayed under the, I know, half and half. So we have this radiolucent dot that is the mental foramen, and we know the mental foramen is a buccal landmark. So this mental foramen didn't change much, but this white dot did. It went in an opposite direction. So then that's how we know that it's lingual, because when this buccal landmark didn't really move much, I guess it moved a little distal, but the white dot moved mesial, they went in two different directions. And when we know that the buccal image, we know that the buccal object went distal, anything opposite that must be lingual. I think that the question on the exam will probably be along the lines of, it probably won't be like, I mean, it's complicated in the fact that it's a buccal object rule question, and that's just a complicated topic, but it probably won't be the most complicated type of question. It should be something that gives you a pretty clear buccal landmark to center yourself on, and then try and answer it based off of what you know about buccal objects. Okay. Everybody's just like, okay, the beam has moved. 7 more questions. The beam has, oh, I did it again. How many buccal object rule questions did I put on this thing? The beam has moved in which direction from image A to image B? So this is our baseline. And then we look at our buccal cusps, kind of went distal. Our roots are leaning very distal. So from A to B, which direction did your beam go? The beam goes in the same direction as your distal. Yeah, good. So the beam is going to go in the same direction as your buccal landmarks. Your cusps went distal, your roots went distal, so the beam went distal. Yeah. Okay, the black arrow is pointing to which structure? The black arrow. Oh, it's pointing not the big red one, but the. What? They do. They might be. The black arrow. I think they are. Basically, what's this? Okay. Yeah. So I don't like this one either. So let me give a few. I don't like this one either. Okay. So I think I should have put the red arrow, because this is your nasal fossa. This is your inverted Y. In both pictures, you're looking at the inverted Y, and this long line is your nasal fossa, and this long line is your nasal fossa. So the area over the premolars is the maxillary sinus. So you locate your premolars, and the line over the premolars is the maxillary sinus. The line over your anterior teeth is your nasal fossa. I think this question was, I need to fix that, because the black arrow to me does kind of look like it's pointing at the maxillary sinus. So those of you who said that, I actually think that seems more correct. And so maybe I meant to write red when I did it originally. I have to change it. But for clarification, because I don't want you guys memorizing the wrong thing, Over premolars is maxillary sinuses. Over anterior teeth is nasal fossa. And that intersection is the inverted Y. There is no zygomatic process seen in this picture in either one of those at all. So that's an automatic wrong answer.
No.
It is, but you can kind of see the arrows pointing like here. This is the red arrow is definitely pointing to the zygomatic from the nasal fossa. This is definitely pointing to the nasal fossa. Whereas the black arrow really truly does look like it's pointing to maxillary sinus. But both of them, this area right here is the inverted Y on both of them. So sorry, that was not a great question. Okay. The radiolucency at the cervical aspect of number 11 is most likely, so this radiolucency right through here is most likely cervical abrasion, lingual caries, root caries, cervical burnout. And it's tricky, but there's a couple things I'll kind of point out to you that'll help. Good, cervical. So the reason why, so those of you who said cervical burnout, I understand why you would put that there, but one thing that you'll notice is look at how sharp this line is. You see how distinct, that's like a very distinct line between this area and here. And so when you see something that's like that kind of stark, and I know that's incredibly small, if I was looking at, I couldn't see it at all. So I understand those of you who are in the back of the room, it's not easy to see it, but when you do it again on your own time and you're closer to the image on your computer, you'll see that it has a very, very like carved out look. And that's why it's abrasion and not burnout. Burnout is like very diffuse, super diffuse. Caries, abrasion, it has much more stark lines, Brandon? Generally speaking, yeah. So a lot of times you'll see that on kind of diffuse from coming in from both sides. So a lot of times, yeah, you would. Five more. Okay, what is the anomaly seen in this radiograph? So what do you see here that looks a little kind of, I don't know so much if it's an anomaly or just, what do you notice here?
I love that. It made me giggle.
The socket from a recent extraction. So good. So here's, it almost looks like there's a radiolucency there. I just was noticing. So that might have thrown a couple of you off, or I guess one person. But do you see how you can see the outline of the roots? So it's not really like an anomaly per se, but it is in your book. That's sort of how you learned about it as an anomaly, but it's just something to note in the x-ray. So as clinicians, you will see stuff and you have to, your mind has to kind of easily say, this is normal, this is abnormal. So if you look at something and you're seeing a change in the bone, if you don't know that it's something like a tooth was extracted, you might be like, what's happening with their bone? Why is it radiolucent and not, you know? But if you're a clinician that understands what you're looking at, you'll say, oh, that's where their recent extraction just took place. So that's the whole part of reading x-rays and being able to understand what you're seeing. And that's why they're calling it anomaly. It's not, I mean, it's not like something weird grew. It's just you're seeing the evidence of something that happened in their mouth. A tooth popped up. Okay, how would you evaluate this film? Retake required, no additional films needed, supplemental film required. How would you, what would you say if you took this film, what would your conclusion be? That you need to retake it, that it's good, or that you need a supplemental? So on this film, your logic, the way your mind should go through this question is that you should say, okay, the second molar is centered. That's good. I want to center my second molar. However, I do not see the apices of this impacted third molar. So I'm going to take a supplemental film. You don't have to take a retake. It's not going to count against you, but you do have to take a supplemental either pano or another PA to try and get those apices. How would you evaluate this film? Retake required, supplemental film required, no additional film required. Yep, retake. So in this film, it's supposed to be a molar shot, and your second molar is way posterior, and you cut off your, so if you had centered your second molar and you still didn't get your wisdom tooth, it would have been a supplemental, but because you didn't center your second molar on the film, it's now a retake. So the criteria for a molar shot is your second molar needs to be centered. So once you go to grade it and determine whether it's a retake or a supplemental film, is based on if that second molar is centered or not. Okay. Name the errors in this pano. Ghost image, chin up, ghost image, chin down, airspace, chin up, mid-sagittal to the right, ghost image. Okay, ghost image, chin up. So your big clues here are the ghost image because you see your earrings. So this is a ghost image of B. So, and then a ghost image of A. Where is the ghost image of A? Oh, here, it's over the tooth. So here's the ghost image of A. Here's the ghost image of B. And then notice how flat the mouth is here. It's just really flat. So you know that if they have that really exaggerated kind of jack-o'-lantern smile, then you know their chin is down because you can kind of do that pull your cheek up and everything kind of gets jack-o'-lantern or kind of jokerish. And then if their chin is up, then everything kind of is flat or looks like they're frowning. So, but since it's kind of flat, then it's a little higher than it needed to be. Their chin needed to come down, and then there's a ghost image. Palatal airspace looks okay. You'd see a pretty dark line right under the palatal, so that looks okay. There is a ghost image here too of the spine though. Last one, then you guys can go. Yay! Can you go after this? Yeah. Okay. Okay. I'm in charge. Well, yes, that's true, but I'm in after my class. I'm letting you guys go. Okay. Name the two errors in this pano: mid-sagittal plane airspace, chin up airspace, chin down airspace. Okay, mid-sagittal plane. Yeah, this one is kind of tricky. I'll admit. It's very obvious that you have an airspace here, and I didn't think that this looked too extreme. But one thing I did notice was that the condyles are almost off the edge. And as far as the mid-sagittal, you're looking for the equal sizing of the teeth, and the teeth look larger over here than over here. that's very subtle. And I hope that a question on the exam is not quite that subtle. But do remember when you are looking for pano errors, if one of your options is mid-sagittal, then look for the equal sizing. Are my molars the same size on both? Is my ramus the same width on both? So, because I was looking, even I forgot what the right answer was, and I'm like, well, I don't think that's too extreme. So I didn't think it was a chin up or chin down. So then you have to kind of compare. And I know it's hard for you to see, but I think that's over here, these molars are a little bigger than this over there. So yeah. See, I feel like if your condyles are often there, then that would have been, sometimes that's with the chin down too far. So that one is kind of tricky. Hopefully the pano on the exam won't be quite that tricky, but that could make your condyles go off the page. Okay, so yeah, like Bob, third place, Anna, second place, and bing bong, ding bong, ding bong, ding bong. And then runners up, set baby, and 2. Good job, good job. Good luck, you guys. Study hard, study hard. You'll do great. Yes.